big attendance today. I want to get going right away just so that we can complete this in a reasonable time and it won't take up too much of your day and everything. I do have a series of slides, and I'm also going to share out a couple of GitHub repositories. They're the same repositories I use in the regular workshop. I'm just going to go through a couple of interesting examples to try to highlight some of the really interesting features in both JUnit 5 and in Makito 3. In terms of slides, I've cut down a lot of what we normally use in the workshop, so it's mostly a summary, and we'll find some way to make those available as well at some point. I don't know what the mechanism for that is yet. So let me start off by sharing out my screen. Now, of course, that's going to throw off my arrangement of windows. So let me do that, and let me see if I can get the chat box back. It's always the chat box that I have trouble finding after that. Okay, so that means I'm going to keep an eye on the chat box. Please feel free to put whatever you like in there, questions, comments, words of wisdom, heard any good jokes lately, you could tell I need material. And you also have the freedom to enable your mic or what have you if you need to do that. Okay, so let me go to the slides to start right off. We're going to talk about the substantial revision of JUnit, that is JUnit 5, or what they call JUnit Jupiter in general. And like so many people, my reaction to seeing that JUnit had changed was, oh no, it's like I understand JUnit 4. Why do I have to relearn JUnit all over again? And I therefore probably delayed maybe a year longer than I should have before I dug into it. And once I dug in, I'm like, wow, this is so much better. This is such an improvement over what we did. And the first thing to tell you, by the way, is that if you're currently a JUnit 4 or even a JUnit 3 user, JUnit 5 can still run all those tests. It takes a little bit of extra configuration in the build tool, but it's easy enough to do. Michael, I don't know, is this session being recorded? I think it is, right?
Ooh. Why
Yes,
can't?
it
Oh,
is.
there
I
it
see the
is.
recording. Yep.
Yep, it is recording, and there is a place for the slides. So as long as the slides are uploaded onto the webinar description that I think you have, Ken, then both of those should be available at nofluffjuststuff.com. And in
Okay.
fact, if you go there, all of the webinar recordings are in reverse chronological order on the lower right hand portion of the page.
So the slides are not updated there now, but I'll upload them as soon as we finish. I'll put them all up there. But interesting that you like the dynamically generated test. That's actually something. It's still considered experimental, which we're going to get to, but I'm not really going to dwell on because again, it's experimental. But I'd love to hear what you do with it because I have yet to find anything that I could do with dynamic tests that I couldn't do with parameterized test instead. But that's a different issue. But yeah, please feel free to keep in touch. And speaking of that, here's my contact information. Deep method stubbing. Not sure exactly what you mean by deep method stubbing instead of just regular stubbing, but we'll get to that too. Any rate, my name's Ken Kousen, as Michael said. There's my contact information, my email address, homepage, blog, Twitter handle. And like so many people, I have a free weekly newsletter. It comes out every Sunday. You're welcome to take a look if you're interested in what I'm doing. And these are the books I've written in the past. I will mention that all of my tests in the Kotlin cookbook, the one that came out last December, are using JUnit 5. I mean, there are Kotlin frameworks for testing, but I couldn't figure out which one was going to win, and I didn't see anything that was any better than what JUnit 5 could do. So I just wrote the tests in JUnit 5 in Kotlin, interestingly enough. The modern Java recipes also uses JUnit 5 as it turns out for all of that. All right, moving on. Here are the GitHub repositories that I'm going to be using, and I'll paste those into the chat box here. Yeah, random tests, right? Let me copy this also. So I have two separate repositories, one for just JUnit and one for Mockito. And also it's got some examples using the Hamcrest matchers, which we don't care about today, but they happen to be in the same repository in case you're interested. All right. Now, the only weird part about JUnit 5 is the naming, that they have decided to separate JUnit 5 into the platform and then Jupiter, which is the programming and extension model. and then vintage. Now the vintage part, that's easy. That's the part that runs JUnit 4 tests and JUnit 3 tests. And I have some examples in the GitHub repository that use JUnit 4, and that works just fine. It's the distinction between the platform and Jupyter that as a user, I don't really care about. If I was working on the platform and trying to improve JUnit, then I'd care. But I'm not. I'm just a user of it. And therefore, I don't really make a distinction here. In fact, the only time it comes up that there's a distinction between those for me is when they release a new version and I have to check out the release notes and they put down the notes under platform or under Jupyter. Now, why Jupyter? Well, first of all, it gives me an excuse to show a Juno picture, a picture from the Juno satellite go around Jupyter. But really, seriously, how silly it is. Which branch to pick up from JUnit in GitHub? Somebody asked me that as a direct message. It's the master branch. I had an NFJS virtual branch for the last time I ran the workshop, but I just merged that into master now. So the master branch is fine. I may do some cleanup on that later, but that's where we are at this point. So at any rate, Jupyter starts with the letters JU, just like JUnit, that's the reason. And it's the 5th planet from the sun for JUnit 5. Makes me wonder if they're going to go to Saturn when they go to version 6. I have no idea. But at any rate, that's, again, just mostly an excuse to show the cool Juno photos here. Now, the parts of this are completely understandable to regular JUnit users. Like the @test annotation still works, but since they support JUnit 4 as well, they made the similar annotation in a different package. And the JUnit 5 packages all have the word Jupyter in them, and you could annotate them with that. And that's how JUnit distinguishes between the current version and previous. Now, not all of the things are like that. They did change, for example, I'll get to these in a moment. They did change the lifecycle annotations so that, again, you could just look at a test and know which one you were in. But in addition to just @test, there's repeated test, which I don't use very often because it runs the same test over and over again, unless I have something variable in the test that doesn't really do much for me. But parameterized test is awesome. And that just became final or released. It's not experimental anymore as of JUnit 5.7, which is, I think, a couple months ago became official. So that's really one of my favorite capabilities. And the comment earlier in the chat about the dynamic tests has to do with @test factory. That's a method that will generate tests for you. So it's very useful when you have an indeterminate number of tests, like I want to cover a certain part of the space locally, but if I have a lot of time, I'll cover a much bigger space. But again, that's experimental right now. I don't want to get too much into that. The life cycle annotations have changed. In JUnit 4 and earlier, we had before and after, and we had before class and after class. Now they're called before each and after each, which is normal. And we have before all and after all, which means run once before any of the tests and once after they're all completed. One of the changes is that before all and after methods have to be static now, because the before all runs before they even instantiate the class. And this brings up an issue having to do with lifecycle. In JUnit 4, the test class is reinstantiated between each test. That's normal behavior. In JUnit 5, you can actually customize that. If I go to my GitHub repository here and I bring up my lifecycle test here. So this is lifecycle test. You can see I've got a printout to say I'm in the constructor. Here's a before all method. The name's arbitrary. And a before each method. And then I have 1, 2, 3 tests, and then an after each and an after all. And don't worry about the details of this. We go into it in the actual workshop. But if I execute this, you will see that the before all happens even before the class is instantiated. That's why this has to be static. And then before each test, after each, constructor again. Before each test, after each, constructor again. Before each test, after each, and then after all. So the class is reinstantiated between each test. And this is normal behavior for JUnit 4. But do you see this annotation here, test instance with a life cycle? That can either be per class or per method now. And if per method's the default, and if I change it to per class, then what you'll see is that now the constructor is invoked before any of the tests are run. And then you do before all, which, by the way, no longer has to be static. And then the the trio of before each test and after each, before each test, after each, before each test, after each, and then after all. So now you can customize this. And for example, the Spring framework, which has the Spring Boot test annotation, includes JUnit 5 as an extension. So it's already built into Spring right now. They recommend going to per class because they manage the test bean as a singleton anyway. So at least now you have the freedom to switch if you wanted to. So at any rate, those are some of the lifecycle annotations that are new now. Now you can disable a particular test instead of doing ignored, and I'll show you one of those in a minute. And you can now change the display name. These are a couple taken right out of the user manual. Instead of putting in some complicated name, you could put display name with a string. This is basically illustrating that it supports Unicode. So you could put in the guy flipping a table or the Munch scream. And in fact, part of my GitHub repo here, it consists of examples that were taken from the user manual. I tried to identify where that happened. So here's a custom test name containing spaces. And again, if I execute this, you'll see the guy with the flipping the table and the scream and everything. I can't really magnify that, unfortunately, but it shows up on the test report as well, assuming you have the right fonts available. But it's really just an illustration that they support Unicode on all this. I do like the idea of being able to write a custom test name that's a lot more descriptive. And that is, in fact, what shows up on the GitHub repository. I mean, the Gradle build, the Gradle test report, for example. In fact, let me show you that. So here, let me run my Gradle test. And when that completes, I can open under build, reports, test, index.html. That's the normal place that Gradle puts the test report. And you can see there's all the tests. And here are the various classes. And I've got some ignored ones in there. But if I look at those display name tests, you can see I happen to have the right fonts on my machine. So you can see I like this idea. I don't like changing the name of the class because then makes it harder for me to find the test. I have to remember that it's actually this class, but you can change the name of the class as well. All right, now where life starts to get really interesting is with the new assertions. These are the assertions that everybody has used in JUnit, true and false and all those equals overloads and null and not null, same and not same for reference equality and fail. But these are the new ones, and some of these are, actually, I use all of these now that I think about it. Assert all finally allows us to run multiple assertions in a single test without the first failure making the test quit. You will get all of the assertions running. And Assert Throws is the new mechanism for asserting that exceptions occur. And then these timeouts are great. So here is, let me close this. So I have one called Assertions Demo. And here is the normal assertion. Now, one thing to point out is if you put in an error message, it now comes last instead of first. And then you could also put parentheses arrow to the left of it. And what this does is it makes it a string supplier rather than a string. If I look at the docs here, it says assert true takes a Boolean and a supplier of type string, which means the supplier is only evaluated if the test fails. They actually have that built into the framework. So this is one of the ways they've taken advantage of the functional features added in Java 8, which I guess I should have mentioned. This does require Java 8 or above, but that's not exactly a big barrier anymore. So that's one nice thing. And then let me scroll down a bit. Here's an assert all. So if I have a Pojo here, just this book class, say I was retrieving it from a service somehow, I'd want to test all the properties of that book. I don't want to have 4 different tests because if in JUnit 4, if the first test fails, the whole test is aborted. By wrapping them all in assert all and making them all into lambdas, these are called executables, then I can guarantee that they will all run even if some of them fail. So of course that one passed at the moment, but if I take the X off and take a space out of here and put that in the future or something, let's make that 23 and run this, now I'm going to get some failures. And you'll actually see, let me scroll down a bit. There were 3 failures and it identifies all of them, and yet it ran all of the tests. So let me just undo those changes so it's still working. So this assert all is really convenient. I use that a lot. Now you can actually nest these things. You can say assert all, and that means this lambda will run, and this lambda will run, and this lambda will run. But inside this lambda, I have an assert not null on the title. If the title's null, then the rest of this particular test in the middle here is aborted. And then so you can short circuit if you want. So this is basically nesting assert alls just to show how you could build up whatever short circuiting behavior you want. Now, another interesting one is the assert throws, which now lets you do your little test here. I made an array list and tried to access it beyond the end of the list. That should throw an index out of bounds exception. But not only does that check that the exception is thrown, it returns the exception so that I could check the message or whatever as well. So that's another nice feature, is that now you specifically say what you expect to throw the exception, and you can get the exception back and do further tests on it. But this is the cool part with the timeout. See, this assert timeout takes a duration. I'm going to wait 100 milliseconds, and I'm just going to print hello. And that's going to pass because it doesn't take me 100 milliseconds to print hello. But what I have here is assert timeout and assert timeout preemptively. The first one sleeps for 200 milliseconds, so that's going to fail. And so does the second one. So they're both going to fail. But the interesting issue is that they'll fail differently. If I disabled this, that's so I was able to show you that the test passed. So let me re-enable that and run this test. And what you see happens is that not only does it say it exceeded the timeout, it tells you by how much. So in other words, this one executes in the same thread as the test and doesn't interrupt it. It waits until it completes and then tells you by how much you failed. Whereas here, if you don't want that behavior, you can do assert timeout preemptively. And in this case, it will wait until the duration is over and then interrupt it. It'll kill the thread. So that's running in a separate thread. And this way you can choose whichever behavior you want. Yeah, assert timeout is interesting, right? So some people have used that. I really like that. I think and it's very easy because you don't have to write any of the threading code. It'll do it all for you. Also, this sleep, as so many Java developers know, sleep throws an interrupted exception, which is a checked exception. This executable that we're using here, this lambda, represents what they call an executable. That's a functional interface whose single abstract method throws a throwable. So JUnit catches the exception. You don't have to catch it. You could just write your lambda and it'll be caught automatically. And also that executable is the same one that was used in assert throws as well. So these are a couple of really nice additions inside there. Okay, now back to here. I mentioned all this, so I'm going to skip that in the slides, but they're all the stuff I mentioned. They also have assumptions now, which is kind of interesting. An assumption is a precondition check so that you could put in a test that something is true before you invoke the actual test method. And if it's not true, the test will be ignored, basically. So as an example here, here's my assumptions demo, and I'm just using a stack, which has been in Java since version 1, believe it or not, even though it's been refactored half a dozen times. What I want to do is call pop on an empty stack. And you're never supposed to call pop on an empty stack because that will throw an empty stack exception. So the way you could handle it is to say, all right, let me get the size of the stack right away. And I'm going to assume true that the size is greater than 0. Because that's the precondition on calling the pop method. Here I would call pop, and then I would check that the size of the stack went down by 1. But the idea here is because the precondition is false, instead the test is aborted, ignored, assumption failed. So that we never actually call the pop method, which is neat. Java's never had that built in. There've always been libraries to do that, but now it's built right into JUnit. Okay, somebody told me they had difficulty importing the project. When you import the project into Intellij, be sure to import it from the build.gradle file. navigate to the build.gradle and have it set it up that way. And there is no special plugin or anything that is needed, but it does, your IDE does need to understand that this is a Gradle based project. Then it'll set everything up and run properly. Okay. So yeah, this assume true and assume false could be used for not implemented features. Absolutely. And it's, yeah, the only difference is that in the failure message, because this one shows up as ignored rather than a failure. See, I don't know, you can't see that, but it's a circle with a line through it, you know, and in fact, it showed up on the output here as ignored in the test report. So again, it avoids calling something that you know isn't ready to be called, and that's an assumption. See, Java has never had precondition checking in it, and they use exceptions for that. And according to the testing literature, that's a bad move, but that's the way Java's always been. So now we have assumptions in case you want to use them. You don't have to, of course, but that's the only difference, right? It's as it fails. Now, here's another neat thing in JUnit, and I really like it because this is incredibly easy. Okay. What they've done is they have these annotations now called enabled on or disabled on operating system or JVM version, also system properties and environment variables. So there's an OS enum that has operating systems, and there is a JRE enum which has Java versions. And if I show an example here, this is my conditional tests here, then this is enabled only on a Mac, so this will run on mine. This is enabled on Linux and Solaris only. This is enabled on Java 8. This is on 10 and 11 only. This is enabled for a JRE range from 8 through 11. And then this one's on a system property, and a system property with a regular expression, by the way. There's a little regex. It's a 64-bit architecture. And this is for environment variables. And you could even put in a custom condition where you write a method that returns a Boolean, and then this will check and see whether that Boolean is true as to whether this test runs or not. So the neat thing about system properties is you could set them on the command line, you know, with a -D. And with environment variables, well, you can set them in your operating system. So right now, for me, this will run the Mac one, and I'm currently on Java 11, so this will run, and so will this one. But these will not unless I set the system property and the os.arch property, which actually I think this one will run on mine. I think I am using a 64-bit architecture. And then this is an environment variable. So you see how easy all those are. You just use the enum that's available, and the test is either enabled or not, depending on whether those are true. And if I just execute it, just to, again, to give you an idea what it looks like, it's a question of whether they're ignored or not on all of these. Some are ignored and some are not. And that's really simple. And this bottom one here about writing a method that has to return a Boolean and using that for a custom condition, that's brand new in JUnit 5.7. And it's really, again, easy to use. So I like that as well. Okay. So I'm just listing them all on the slides, the environment variables, the system properties, okay. Now, another thing you can do is you can add a tag to your tests, classes, or the individual tests. And then these tags, you could actually have multiple tags. The tags are checked in the build file. This is an example from Gradle, but they work in Maven as well. You could specify which tags are being executed in the build file. So I could have it so that I'm running all the fast tests or the smoke test and feature A together. You know, if I have both those tags on a test run, or I could exclude slow tests or CI tests. So the other one, the conditional tests I was showing were programmatic. This allows me to just add arbitrary strings, not quite arbitrary, but more or less arbitrary, and then specify in the build file which ones I want to run or not. And that's, again, something that we've wanted for a long time. And they had sort of in JUnit 4, but now it works great in JUnit 5. I mentioned the life cycle already. So let me skip to this part, which is the other big feature, the parameterized test. So the idea in parameterized tests is you're going to run the same test multiple times, but with different data. So you must say where the data is coming from. You have to have a source, and a value source just uses simple arrays of primitives or strings. An enum source takes values from an enum, and you can filter those. A method source allows you to specify a method that returns the values. And then there's the one from the drugstore, the CVS, I'm sorry. Yeah, a CSV source. So for comma separated values, yeah, it's really bad if you laugh at your own joke too, isn't it? Awful. At any rate, you can also put those in a file, and then an argument source allows you to specify multiple. So let me show you an example of that. Oh, good. Somebody's laughing. So you know, I just can't help seeing that when I look at it. You know, any rate, this is parameterized test. Okay.
And for what it's worth, I often now include a laugh track in my presentations. I just have a button I can hit, and then it'll broadcast a little titter of laughter. And
I need a rim shot button, you know, for something like that too. Anything for ordering, as someone's asking. I wasn't planning to talk about it, but yes. And in fact, if you look in here, I have an ordered test demo. And the idea is you have to specify that you want an order and that you want to use the order annotation. So here I've got the order annotation, and it doesn't matter what the numbers are, as you can see, they'll order from minimum to maximum in that. So that in general, you don't care about this because normally you want the tests to all be independent. But if you really did care and want the test to run in a particular order, so you might as well laugh. At any rate, then there is a mechanism for that, yes. And again, this is taken directly out of the reference manual, which is excellent. I didn't show you that, by the way. Here is the homepage for JUnit 5, and it's just junit.org. It'll redirect to that. There's a user manual here and the Java docs, and the user manual is very well written and thorough and has lots of information in it, and you know, things about parameterized and nested and everything. Lots of good stuff in it. Okay, so back to the parameterized test. Oh, well, I like that comment from Gary. That actually worked with CBS. Any rate, let's start with this one. This is a value source. So this says the name is whatever the argument is prime and less than 20. And notice that on this method, now the method has an argument. The test method has an argument. And the argument is supplied by each element of the value source in turn. And I'm checking, I have a utility class where a method's called isPrime to see that these are prime numbers. So when I execute this, you actually get a separate output for each of the value source variables, which is what I want. I really am running 1, 2, 3, 4, 5, 6, 7, 8 tests here. And here's the composite ones just to make sure I didn't just return true. You know, those are all in there as well. And that's the value source. Now with the value source, the arguments are arrays of any of the primitive types, as well as strings and classes, although I haven't come up with a use case for classes. But for strings, I've got one of those too. But here is a method source. Now, this one says, okay, I'm going to check all the primes less than 100 and run them all through there. So where are these integers coming from? They're coming from a method here called primes less than 100, which is right here. And the requirements for the method are it can't take any arguments. It has to be a static method. They refer to it as a factory method in the docs. And it has to return something that Java knows how to iterate over. So a stream, an array, an iterable, an iterator, something like that. And if I run this, then again, it will execute all of the values, test for all of the ones that come back from this automatically. And that's really, really convenient, very easy. And I've been making a lot of use of the method source, you know. Again, that's why I don't use the dynamic source that much. I mean, everything I've ever come up with as a dynamic source, I've been able to go, I could do that with a parameterized test without it, but so be it. Let me move on. Instant rimshot.com. Oh no. Somebody sent me a link to a website where I could actually get a rim shot there. Oh, boy, that's dangerous. Now, one other thing to show you before I go to the more interesting ones, notice this one's taking 3 arguments. See, the others just took a single argument. This takes 3. Now I want to write out the max of X and Y is this, so 0, 1, and 2. And I want to get back a method that produces them. And here's that method. Well, that's where the arguments class comes in, because the arguments class has an of method that lets you wrap multiple arguments into whatever single object you want. So I'm returning a list of arguments, and that's what this will do. It'll run the test for each of these triples. Max of 2 and 1 is 2, 7 and 3 is 7, etc. So that all works fine as well. And by the way, these are all the same type, but that was not necessary. They could be any arbitrary types. I think the argument of the of method, the document is object ... So you could mix and match types, and they can be converted as well when you specify the data type. Now, here, oh, and by the way, this is just showing strings as well as a value source, and month enum also. They could say they're all not null. Here's the example from the user manual with an enum source where I go to all of the chrono units that match this regex, which says it starts with any number of letters followed by the word days, and that's at the end. And then it just, the assertion here is that the name ends with days, and it will. And it turns out the values are half days and days. Yes, this is being recorded. That's right. Now, here's the CSV source. You can specify your comma-separated strings directly. And the delimiter, by the way, is something you can set. You can change the delimiter if you want. So what happens is that this method, or JUnit rather, will parse the strings at the comma and then supply them as arguments here. So you could see them all individually running one by one. And it's like, okay, but what if I don't want to hard code them in there? This is the, actually, let me skip to this one. This is the CSV file source. See, CSV file source, I put my data in a file, and I even put a header on it to identify where the data is coming from. So I could say, read this file, skip the first line, and the delimiter is, even though that's the default, I just thought I'd show that you can in fact put a delimiter in there if you want. And then I'm just, it not only does it put the 4 components in here, 3 of them are strings, it actually automatically converts to a local date as long as I use the ISO standard syntax for dates. So there's a lot of automatic conversions that happen too. And you could even make your own aggregator if you want. So everything here is written in terms of a book, and I can even make my own annotation, but that's way beyond, you know. So at any rate, that's a lot of the stuff that JUnit 5 can now do. And it's really straightforward, and the docs are excellent. And I just hate going back anymore to JUnit 4. As an aside, before I switch to Makito, let me mention that in this repository, I have a sub-project which has a Spring Boot example inside it. So that's actually using Spring Boot as well. And I have a sub-project called Vintage, which is just doing some JUnit 4 tests as well, just to show that there's no reason I can't still use those also. And I'd have to show you the build files and everything, but they all work just fine. Okay, feel free to keep mentioning questions or comments about any support for JSON data. I'm waiting for somebody to ask, do they have YAML support yet? You know, not at the moment, or at least nothing built right into the framework, but they do have extensions. That's what actually I should have mentioned that. They have extensions here. If I go back to the JUnit page and I go to the GitHub repository. So this is the GitHub repository. There's a wiki page here which lists various extensions. So I don't know how often they update this. Okay, so I'm not sure if it's up to date or not, but there are extensions for various test engines and for these Jupyter extensions like the Spring one that's already built in. And I know there's at least one and maybe 2 or 3 for JSON stuff. I just haven't tested any of those, no pun intended, myself. So with the caveat that I don't know how often they update this, there are third-party extensions. You could find a pretty decent list on the wiki page at the GitHub repository. What coverage reporting tool you recommend? They haven't said anything that changes the normal coverage tools, you know, in JUnit. So the only one I've ever used is Cobertura, and I know there are others and arguably better ones, but I've used Cobertura. Those are puns, you know, always like the puns. Yeah. Anyway, so I just stick with that one, but I know there are plenty, and I don't think JUnit, the changes in JUnit have not affected the code coverage tools in any direct manner, as far as I know. Okay. All right, now let me go on to Mockito. So by the way, in the slides, I talk about those various sources. And the dynamic tests, I'm not going to get into it now, but it's still considered experimental. Then there's the extension, especially the Spring one. Please paste the GitHub JUnit 5. I did actually. It's already, both GitHub repositories are at the bottom. Oh, I guess it scrolled off of that. Yeah, I'll paste them in again at the end. All right, so again, there's the link to the extensions. And now let's talk about Mockito a little bit. Now, Mockito just changed to version 3 within the past 6 months, but it didn't really change anything. It just said, okay, now that we're Mockito 3, you must have Java 1.5. Oh, thank you, Kathleen. I appreciate that. She pasted the links to the repositories back in the chat box. At any rate, Mockito 3 just says, yeah, we required Java 1.8 or above in order to run. And they didn't really change the API or anything else like that. One of the things I've found is when I start talking about the Python books have to be Jupyter with a Y, right? Yeah, probably. Actually, I think the Python books came way before the JUnit people moved to Jupyter. So I don't know. Maybe it's the other way around. I don't know. At any rate, one of the problems I find with Mockito is a lot of people don't get what Mockito is trying to do. And worse, the documentation is written assuming you already know everything. I mean, it really is just, how do I use Mockito to solve these problems when they don't really explain what the problems are that you're trying to solve. So let me give you a little background, and then I'll show you stuff about Mockito. Do I use Mockito or JUnit for REST APIs? I use JUnit for REST APIs all the time when I'm using Spring, because then I just use either the Spring web client or the test REST template to access RESTful web services inside my Spring tests, which are, again, JUnit 5 tests. I would use Mockito with those if my service required a mock object inside it, but those are more unit tests. Just the regular REST API tests, then those are more functional tests, and Spring will allow you to set up a test server and everything. So again, Spring Boot uses JUnit 5 automatically, so all your Spring tests are going to be JUnit 5 tests if you just use the default now. So I think that works really nicely. Okay, now Mockito. Here's an idea. Say you are writing an e-commerce system and you've got a method called process order, and it's going to return a confirmation, and you have to go through all these steps. I got to calculate the cost of the order, all the order items and the quantities, and look up the customer to find out if they're a preferred customer. Do they get any discounts? I have to add in taxes and fees and shipping costs, and then process the credit card. And oh, wait, if the credit card fails, I've got to have something to handle that condition and all this stuff. There's a bunch of steps in here. Now, the part that's a little awkward from our point of view is the credit card charger. Because if I want to run a test, I don't really want to go and charge the credit card. I certainly, not even as a fake that I remove. You know, I'd like to say, no, I still want to be able to run the test, but I'd like a mock object for the credit card charger, so that when I call charge card with a string number on the card service, it just returns a known value, because I don't care about the details of the charge service, the card charger, when I'm testing my logic in the process order method. See, I just want to make sure this method's running properly. I don't want it to be dependent on a credit card charge that I have to then back out or whatever. So I need a mock. Or is it a stub? Okay, so this will appeal back to the old blog post by Martin Fowler all those years ago called Mocks Aren't Stubs, by the way. And the idea is to say a stub stands in for the real object, the credit card charger. And it's hard coded to say, when I call this method with this argument, I want the following result back. I don't know, true or 1 or whatever you want to get back from the credit card charger. That's called setting expectations on the stub. So I say I've made an object, a fake is sometimes the term that's used, that represents the credit card charger rather than the real one. And I want to set the expectation that says, if I call this method with this argument, here's what I want back. Now, a mock goes beyond that. It also stands in for the real object, and it can have the stubbing behavior in it. But in addition to that, you can verify what they call the protocol, the interaction between the thing I'm testing and the mock. And that means I could verify that the methods were called the right number of times in the right order. See, this is all about the interaction between the thing I'm testing and the mock object. See, that's something I would have a difficult time doing myself by hand. I could always write a fake for just saying, oh, this method is implemented this way. But how do I verify that methods were called the right number of times in the right order without writing a lot of logic to do it? You verify a mock. So in this case, I'd want to verify that the customer lookup was called, and then the total price calculator was called, and the shipping service, and that the credit card was charged last, and each was called exactly once. You know, these are all parts of the protocol as well. Mockito automates the generation of both stubs and mocks, but notice that the created object is the same, whether we call it a mock or a stub. The difference is how they're used. The stub provides the known outputs, the mocks verify the protocol, but you'll hear people just using the term mock and stub interchangeably, and they're right until you talk about what it is you are using it for. That's the idea. Now, a spy is sometimes called a partial mock. Method calls pass through to a real object, and they replace, but you can change some of the methods to do what you want and still have a real object for the rest. The Mockito people really discourage the use of spies. They do exist, but they're not encouraged in general. Okay, now, how does Mockito work? Well, Mockito is unfortunately cursed with two completely parallel sets of methods. It's not a good API because the one that people use for years that is their static methods on the Mockito class, like when, where you say, when I call this action on the mock or the stub, I want to return this. And then later they added a class called BDD Mockito. And the only difference is that the methods are now called given and will return, or other ones that are parallel. So it's the same mechanisms, just a different set of method calls. And it depends on which one you happen to favor as to which one you use. There's no difference in behavior of those. So it's a little awkward that way. So how do you create a mock? Well, there's a mock method. There's also a mock annotation that goes with an inject mocks mechanism, because you need to be able to plug in the mocks into the test fixture that you need as well. Now, let me actually go to a couple of examples. Actually, first the docs, because I have to show you something that's, again, kind of unfortunate about the Mockito information. So this is at makito.org. It redirected to site.makito.org. And they say the documentation is at javadoc.io. And you see that all the docs are embedded in the Java docs. So right in the Mockito class, and if you scroll down, they have all these contents and discussions and everything. And these are not organized by anything other than history. You know, oh, first they added in 1, 2, 3, 4, 5. Then they went back and added some zeros. And then they keep adding on and on. You see that since 3.5, there's up to 49 here. So this is not a great tutorial. It really does suffer from lack of documentation. But there's something that's even a little worse here. So for example, let me scroll down to an example here. I pronounce it Mockito. I don't know if anybody else does. At any rate, here is their first real example, and it's very misleading. It says, we're going to make a mock of the list interface, which they say, by the way, please don't mock the list class. Use a real instance instead. You pronounce it Mockito. Yeah, I probably should do that from now on. Very good. Any rate, use a real instance. Any rate, this will create a mock, and then down here they verify that the add method was called with this argument and that the clear method was called. Each of those were called once. But you see here, where's this happening? And that's the misleading part, because the way Mockito's used, you don't test your mock. You're testing a fixture, something you want to actually execute. You plug the mock into it. Remember, that's the fake object that you want to represent something external in order to isolate your class to make a pure unit test. In other words, this mock that was generated would have to be plugged into something else that you're actually testing. And in that test, it would wind up calling those methods on the mock in order for these to pass. And notice they didn't even set any expectations. There's no stub here. Down here, they said, oh, okay, when we call get of 0 on the list, then return first, or when we call get of 1, throw a runtime exception. Once again, these would be called inside the test somewhere, and then we verify it. So to give you, I've got 2 examples I want to show you. I'll give you a simple one here. Here's my Mockito repository. I made a class here called number collection. Because so many of their examples involve a list, I put a wrapper for a list. Number collection has a list of integer in it called numbers. And I put a constructor here to let that list get plugged in. So here are 3, quote, business logic methods that rely on the list. Get the total of the numbers in a loop, get them using an iterable, get them using a stream. So again, I'm looking for things to test, but this is the object I want to test, not the list of integers. So of course, if you're looking at a test here, let me go to my number collection, the first test, which is actually JUnit 4. Okay, you don't have to have JUnit 5 for this. If I go to the bottom, this says, look, let me just make a list. Just create one of my own, like they were saying. And I can plug that in and I can check that the business logic methods work. The problem is there's no easy way to verify that the individual methods on the list were called the right number of times in the right order. See, that's where the mechanism breaks down. I can test the stub, I can't test the protocol. So instead, here I use the mock method to mock my list. I set my expectations. When I call size, I want back 3. When I call get with 0, 1, and 2, here are the values I want out. I plug the mock into the collection, and now there's my test. And not only does this have to pass, see, then I'm just treating it like a stub, but I can also verify that the size method got called once, and the get method was called with any int 3 times. See, that's where you can use Mockito to simplify your life a little bit. I also have the same thing with annotations here. This one, sorry. With the annotations, I annotate my list with a mock, and then I annotate the collection with inject mocks. And this is really cool because you saw how I added a constructor so that I could plug in my mock. With inject mocks, Mockito will say, all right, do you have a constructor that takes this mock? I'll plug it in for you. Okay, you don't have a constructor. Do you have a setter method? And then it'll plug it in with the setter methods. Oh, I don't even see any setter methods. Do you have private attributes of the right type? It will use reflection and plug in the values that way. And then it'll give up. Then it'll say, well, look, I tried everything. I can't get them in there. That sort of thing. But this mechanism will try a lot of work on your behalf to get the values inside. Now, when you move to JUnit 5, I should tell you that the mocks become what they call strict. In other words, if I try to mock a method and I don't call it in the test, it'll say, sorry, you can't do that. It'll say, no, that the test is, you're mocking something that shouldn't be mocked because you're never invoking it. Okay, so this is another interesting little feature. Okay, one last demo, and then I'll be happy to take a look at some of these examples. This is a sample that I adapted from the Spock framework, which I've been using for years. They have a publisher subscriber example that I would like to demonstrate quickly, because this is a great example that shows why you want mocks ever. So this publisher has a list of subscribers in it. It was just an array list. I have an add method. See, this isn't one that's going to have a constructor or a setter or anything like that. I've got an add subscriber method where if this list doesn't contain that subscriber, I'll add it. And this is the method I want to test. Send takes a string, goes through the list of subscribers, and invokes each subscriber's receive method. And if they throw an exception, I catch and ignore it, which is evil, but there it is. How in the heck do you test this? You see, the method returns void. So, I mean, there's nothing coming back. The receive method in subscriber also returns void. So there's nothing to check on that either. How do I test the business logic that each subscriber was accessed and then invoke the receive method? And what happens if there's an exception? Well, this is where a mock is really convenient. What I did here in my publish subscriber test, so here is the publisher test, I said, let's instantiate a publisher and I'll mock 2 subscribers. See, subscriber, I didn't even make it an implementation. This is separate. That's just an interface. So I made 2 mock subscribers. And in my setup method, and then again, this is JUnit 4, but it'd be the same in JUnit 5. I called add subscriber to put the subscribers in there. I can test the send method by invoking send and verify on the subscribers that each subscriber had its receive method called with the proper argument exactly once. See, by using the mock, I can check the business logic in my send method. And if I have a subscriber that misbehaves, throw a runtime exception on subscriber 1 when the receive method is called with any string. So then I called send twice, and I can verify, let's look at this one, that the receive method was called with any string twice on sub 2 and on sub 1. They both got it. And then you could even get more detailed and say, it's not just any string, it's an argument that is a string that matches the following regular expression, the word message and a space and a digit, that sort of thing. So this is the kind of thing you want to do with Makito. I want to test the publisher. The only way I could verify the logic is by going through making sure that the proper methods were called in the subscriber. All right, so to summarize some of this stuff, if you're using JUnit 4, they have a Makito JUnit runner. If you're using JUnit 5, there's an extension, a Makito extension. You can use these annotations. You have to initialize your mocks. Again, that's JUnit 4. JUnit 5, they happen automatically. The argument captor, yep, thank you, is great. I have an example in there of an argument captor. The idea of an argument captor is I say, oh, I'm going to call this method with an argument, or rather, let me say it this way. I'm going to call a test. And in that test, the thing I'm testing is going to call a method on my stub or using an argument. And I don't know what the actual argument was, okay, because maybe it was a local variable or something like that. With the argument captor, I can capture what argument was actually used and verify that it did the right thing. And I have an example of that in the repository as well. Now, setting the expectations, I use some, there are various simplifications for how you can set the expectations. I could chain then return calls. You could do the calls with the do methods in the other order, like when you call a method that returns void or throws an exception. You can verify that methods are called in proper order. I didn't show that, but there's an in order class that takes the mocks as well. And then I verify everything on the mock. The argument matchers were things I showed, like any string or any int, and then I could verify the multiplicity with at least or at most, or I use the times method. And there's that argument captor. I could capture the argument and check the value. And then there's the BDD one. And you can even now mock final types. You have to jump through some hoops to do it, but it can be done. There's the JUnit 5 extension, and there's everything. So again, these are the GitHub repositories. Then answer is good, but that gets a little more involved. If you're interested in more detail, we have the course running, what is it, like the 15th or something of this month? And I'll hang around and answer any questions, but I wanted to make sure at least I got through the basic material by the top of the hour. So any questions, comments? Oh, how do you test methods that print something? Somebody asked me. And in order to do that, you would need to capture standard out. So it's a question of changing the output to make sure that works. And that takes a little bit of doing. Can be done, but it's a little work. But it's not specific to Makito or JUnit. Any other questions, comments? The recording, Michael, you answered that about the recording. Do you want to mention again?
Oh yeah, so the recording is going to be available on nofluffjuststuff.com. In fact, if you go straight to the landing page right now, this webinar today is highlighted yellow with some red text because it's happening right now. But of course, it's going to be in that list and available under the webinars menu, and you can jump straight into that replay as far as I understand.
One of the nice features of Zoom actually is that the processing of the recordings tends to be very fast. I mean, I bet the recording for this one will be available there within hours after we're done.
Oh, sure. Because I think we get pushed a notification when the
Yeah.
processing is done.
Right. And all of our workshops, by the way, are recorded as well. So if you're in one of those workshops, of course, I mean, I did a workshop yesterday on Spring, and, you know, I don't know anybody who's going to sit there and listen to a 7-hour recording, but, you know, they are available.
I like to go through the recordings actually, because what I'll do is I'll go through like one of your half days over the course of an entire day.
Oh, I should
And
have known
so
you'd be the one to, you know.
I
Well,
go
thank you
slow. I
for,
take notes, and I
wow.
learned some tricks from you on the game of school, which I'll talk to you more about later on.
Oh, that comment about using a test factory to generate tests, it's not an IDE thing, it's a JUnit thing. And I do have an example of a test factory in the GitHub repository. Just when you execute the tests and they're annotated with test factory, it produces a test and then all the tests are run individually. So you don't have to do anything special in the IDE or anything special in Gradle or anything like that. It's just, it's part of JUnit. It's bundled right inside. Yeah. Can you mock enums to add new values? I have never tried to do that. Enums are final, so you can mock them now. You have to go, like I say, when you have a mock class, or pardon me, when you have a final class, you have to jump through some extra hoops to do it. But I think you can actually. I think you could mock an enum and say, when you invoke this enum value, which doesn't exist in the real enum, do something else. So it's really more of a stub, but I think, yes, I think you could do that. I just haven't tried it recently. Can you mock static methods? Guess what? As of 3.5 in Makito, you can mock static methods. They resisted that on philosophical grounds for years, saying you should never be doing that. That's a bad move. They finally went, oh, all right. And I haven't added it to the workshop yet, but somebody always asks, you can now mock static methods as well in Makito, believe it or not. Test a custom logger. Again, the trick there is having to capture the output of the logger. So to make sure that the output is correct. But if you use a logger that logs to, you know, some kind of string buffer or whatever, you know, so that that's your output file, then you could capture the string buffer and check the process in there. Is there a way to create test data like the gem, like factory? Nothing built in right now. They didn't decide that was part of their baseline, but it's an open source project. Feel free, you know. Or they maintain, JUnit maintains a Gitter group, Gitter. If you look for Gitter and then JUnit 5, most of the core team members hang out there. That would be the place to ask. But there's nothing in the API at the moment that generates test data. That would be a totally separate mechanism. The static methods no longer require power mock. They used to, but now, as I say, starting in JUnit 5. No, I'm sorry, Mockito 3.5, I think it is. Now they can mock static methods. Test REST endpoints in projects for not using Spring Boot. Yeah, sure. You just need a client. You need well, you know, if you're using Java 11, there's an HTTP client built into Java 11. Or if you're not using Java 11, there are great libraries out there like OKHTTP or Retrofit. Or heck, Apache has an HTTP client. Just do the call to the client inside a JUnit test and verify you got back the results you're looking for. Fake it until you mock it. Hey, that's a good one. I like that. And then there's WireMock. Yeah, that's a whole thing. Should rename it WireMock. I got nothing after that one.
All right. On that note, maybe it's a good time to wrap up. But once again, a huge thank you to Dr. Ken Kousen, the Groovy Doc. Is that still a moniker that sticks around, or has that
Only with
come and
you.
gone? All right. Well,
Yeah, especially because I spend more time with Kotlin now than with Groovy, sadly. But
well,
there it is. So.
I will carry that just because I love the pun.
Sure.
Well, let me ask you this before we go, Ken. Do you have a Ken joke to leave us with?
I can give you the prime number joke since I did all those tests with primes. Should I do
Let's hear
that?
it.
Okay, one question math test: prove or disprove that all the odd numbers are prime. So the mathematician goes, well, 3 is prime and 5 is prime. Therefore, by induction, all odd numbers are prime. That's funny if you know a lot of math. The physicist goes, 3 is prime, 5 is prime, 7 is prime. Oh, shoot, 9. That could be experimental error. 11 is prime, 13 is prime. Yeah, that's good. And then the engineer goes, 3 is prime, 5 is prime, 7 is prime, 9 is prime, 11 is prime, 13 is prime. The computer scientist goes, 3 is prime, 5 is prime, 5 is prime, 5 is prime, 5 is prime. And the manager? 2 is prime, 4 is prime, 6 is prime. So there you go. Feel free to reuse that if you like it.
All right. Thank you all so much for joining us today. And do check out all that is on offer at nofluffjuststuff.com. And I look forward to seeing you at another one of these soon and at one of our in-person events in due course. Until then, stay healthy, stay safe, and stay sane.
Yeah. Thank you for coming, everybody.
Thanks, guys.